All right, so for day 3 of 6.5, we just want to have a little summary sheet for you. Okay, so I am going to go faster because this is stuff that we've done for 2 days, but it's a good resource for you to have in the future. Okay, so anytime that you are factoring, right, you are going to factor out any GCF to start. Okay, it makes things much easier in the long run. And after you do that, you look for the number of terms and factor appropriately. Okay, so difference of squares, remember, take the square root, and then one's a plus and one's minus. Okay, notice how this is to the fourth, so that means that when you square root that, you get squared. Okay, sum of difference of cubes, you follow this formula over here, okay, which I will be giving to you. So this is almost perfect, but there is a GCF of W first, and then you have difference of Q. So the cubic root is 3W minus 5Z. And then we use these to fill out the rest. 3W squared gives me 9W squared. Multiply 3W and 5, and you get 15WZ. And then 5Z squared gives me 25. Now, 3 times, you have to remember, terms less parts. Okay, I'll always pretty much do parts. Okay, again, here's some instructions for it, but essentially, remember, all you do is first times last, right, which is negative 24. You need to multiply to that and add to 10. And then we would pick 12 and negative 2. Then in our denominator is always our a value, and whatever our middle term is for x's. Reduce if you can, which you can on both sides here. So we would divide both by 4, and you get 3 over 2x. And this one would be divisible by 2, which gives me negative 1 over 4x. And then you write it bottoms up. 2x plus 3 and 4x minus 1. Remember, it doesn't matter what order you put those in. If it is a higher degree, put multiple is higher degree, right? Higher degrees, you do the exact same thing, except instead of an x in the denominator, you use whatever it matches the middle, right? So in this case, our first times last would be 1 times negative 2, which is negative 2. And we need to add to a positive 1, so we would have 2 and negative 1. This time, our a value, that's the third that goes in the denominator because it needs to match the x value in the middle. I should say x degree in the middle, not its value. So we can write it bottoms up, x to the third plus 2, and x to the third plus 1. Now, most of you are probably thinking that's your final answer, but this is actually the difference of cubes. So you should go further and say x minus 1, because that's the cubic root of both. Then we would have x squared. Then we multiply them to get x. Then you square 1 to get 1. Obviously, x cubed plus 2. 2 is not a perfect cube, so we can't go further. And then 4 terms, we only have one option, and that would be to group it. So we group the first 2 and the second 2. First 2 we can take off an x to the third. You're left with x squared minus 4. The second 2, you can take out a 27, and you're left with x squared minus 4. So our final answer would be x squared minus 4 and then x cubed plus 27. The problem is both of these can actually be broken down further. This is the difference of cubes, which would be x plus 2 and x minus 2. And this one's the perfect cube, right? So it's the sum of perfect cubes. So we would have x plus 3. And then we would square the first one, which is x squared, multiply them as 3x, and square the last, which is 9. So this would be our final answer. Now, most of you are probably thinking, and maybe you thought this on the first day as well, is that this is a t-chart one, right? But if you try to t-chart it, there's nothing that multiplies to 9 and adds to -3. You would have to do a quadratic formula to solve that one, which is what we'll do today. Okay, big thing is you want to factor completely. After factoring, you want to check and see if you can keep going, okay? I'm actually going to change the color so this makes you really look at it, okay? You have to always look to see if you can go further, okay? So the last thing that we'll talk about today is just solving, okay? We already know this. If you're asked to solve, you just have to then try to get it to set each piece equal to 0 and solve, okay? Some factors, like I just said above, may need to be solved with the quadratic formula, okay? So looking at number 1, this is a 4-term thing. So anytime 4 terms, we are grouping. So if we group the first 2, I can factor out a GCF of -2 and an x squared. You'd be left with x minus 5. And the second 2, we can factor out an 8, and you're left with x minus 5. At this point, we would factor out the x minus 5s, and you'd be left with -2x squared plus 8. Now, hopefully we can realize that the second set of parentheses, we probably need to do something here, right? There is a -2 out in front, and with the -2 and the positive 8, you can factor out a -2. So if we do that, tack it on in front, and that one now becomes a positive x squared minus 4. Now again, hopefully we recognize that that means that this is the difference of squares, okay? So now we would square root both, and we would get x plus 2 and x minus 2, okay? In the very, very, very beginning, you could have recognized that you take out a -2 just to start, and you would have ended up in the same spot as where we are now. So that is our factored form. Then we would just need to set each equal to 0. As we know, this -2, if we do -2 equals 0, that really doesn't mean anything. Yes, if that was our only answer, that would mean we would have no solution, but we have all these other solutions to worry about. So if we set x minus 5 equal to 0, we would get a positive 5. X plus 2 would give me a -2, and x minus 2 would give me a positive 2. So if you look at number 2, hopefully we can recognize that we would factor out a 2x squared, and you'd be left with x to the 4th minus 2x squared minus 24. At this point, that is a trinomial that we can t-chart. So first times last gives me -24. We need to multiply to -24, add 2, 4, and that would be -6 and 4. Now this time, remember, we are putting in x squared because it does match whatever is in our second term here, okay? So our 2x squared stays on the outside, and now these two turn into x squared minus 6 and x squared plus 4. Now, a lot of you probably recognize that x squared and 4 are perfect squares. The problem is it needs to be a subtraction in order to do what we did over here. Okay, so because it's not the difference of squares, we can't do anything to that one. We actually are stuck here. So we get 2x squared, and then x squared minus 6, and x squared plus 4. Now, this time when we set 2x squared equal to 0, if we would divide by 2 and take the square root, you would end up getting 0. Okay, now, no, there's no positive and negative 0, but we know that. The next one is x squared minus 6 equals 0. We would add 6 and then take the square root. Now, remember, when you take the square root, it is a plus or minus. And we don't know the square root of 6. And then our last one, x squared plus 4 equals 0, we would subtract 4 and take the square root. Now again, we need a plus or minus. Square root of 4 is 2, and because it's negative, we need our I in it. Okay, we're bringing back everything that we did in chapter 5. So these would be all of our solutions. X equals 0, plus or minus the square root of 6, and plus or minus 2i. Number 3, okay? Hopefully we recognize that this is the difference of cubes, right? Okay. So from here, okay, notice how I said 4 to the third, not 8, right? Yes, there's one of those that is both a perfect square and a perfect cube. So please be careful when you're doing anything with this one, okay? So remember we take sorry. So we have x minus 4. Then we use this to figure out the rest of it. So first term squared would be x squared. If we multiply x with 4, we get 4x. And then we square the last one, 16. Now, anytime you do a difference or sum of cubes, you are going to do quadratic formula with this part. You don't have to memorize that, but if you were to try and t-chart this, there's nothing that multiplies to 16 and adds 4. Okay, so factor form stays exactly what I can't get any further. Solutions, obviously the first one is 4. The second one, you have to use quadratic formula. This should be plus or minus b minus 4ac all over 2a. So, okay, so we end up having negative 4 plus or minus, and this minus 4, which actually ends up giving us a negative, right? So this would be negative 48. All of it. Okay, now, if you got that far, I'd be pretty happy with that. But remember, 48, we can narrow it down, right? So this would be 2 and 24. 24 is 8 and 3. 8 is 2 and 4, and then 2 and 3, right? So we can rewrite this as 2 times 2, which is 4, root 3 over 2. Now again, that's another acceptable answer, but I would go from here to here by dividing by 2. So it's actually negative 2 plus or minus 2 root 3. And you could put a 1 in the denominator, but the only reason why we can simplify that again is remember all 3 terms are divisible by 5. All right, and then number 4, okay, 2 terms, a lot of different stuff going on here. So hopefully we can see that we have x squared. When you do that, you are at 4 minus 16. Okay. Now, anytime you have an x squared or an x to the fourth, we need to see if they are perfect squares, and they actually are here. Okay. If you take the square root, you get x squared and 4. So one's a plus and one's minus. Don't forget to drop down the x squared. And hopefully we are quick to recognize that this is also a perfect square, right? So everything else stays the same, except this becomes x plus 2 and x minus 2. Okay, notice how we did not do x squared plus 4 because that's not the difference of squares. So we have all of our factored form ready to go. Obviously, if we said 3x squared equals 0, we would get 0. And same with these, x plus 2 equals 0, x minus 2 equals 0. We know these two to be 2 and negative. You don't have to show all that work. When you set x squared plus 4 equals 0, you would subtract 4 and then take the square root. And again, anytime you take the square root, you have a plus or minus. Square root of 4 is 2. There is a negative, so we would have to have an I with it as well.